Alright, so for 2-6, we're going to be verifying angle relationships. We've talked a lot about angle relationships, but here are all of your theorems, postulates. So theorem 2-2, if two angles form a linear pair, then they are supplementary angles. Bless you. I gave you a definition of a linear pair earlier in the chapter. This is the official theorem behind that definition. So these are statements that you're going to start to use in a proof. So if you're told that two angles form a linear pair, your conclusion in the next statement of your proof ought to be the two angles are supplementary. And then your next statement from there should be that the two angles add up to 180 degrees. Then we had this on that little sheet from 2-4. Congruence of angles is reflexive, symmetric, and transitive. So we can use any of those properties in our proofs regarding angles. And then this is the shorthand notation that you can use in the reason section of your proof. So feel free to use any geometric symbols. So last night you were using the reflexive, symmetric, and transitive properties of congruent segments. Technically you're supposed to have that notation attached to the end of reflexive, symmetric, and transitive. If you're dealing with segments, it would say congruent segments. If you're dealing with angles, it would say congruent angles. Theorem 2-4, angles supplementary to the same angle or two congruent angles are congruent. This is a test question next week, and I'll show you what it will look like. Do you have a slip, Melissa? Yeah. And then what I have here in green would be the shorthand notation that you can use on the reason part of your proof. So instead of having to write all of this, you can write it in shorthand. Unfortunately, this theorem doesn't have a name, so you do have to write out the whole theorem in that reason part of your proof. Brianna, if you can't see, you can move to where there's light. If that's hard to see, feel free to move. In fact, Megan might switch with you. Would that be okay? Yeah. Okay. Thank you. All right, so here's an example of how this question might be asked, and if I were you, I'd write it down. So it might look something like this. Angle A is supplementary to angle C. Angle B is supplementary to angle C. That's what you're going to be given. That's statement 1. And isn't that basically saying angles supplementary to the same angle? Aren't these two angles supplementary to the same angle C? Let's put some numbers to those angles. Let's say that angle A is 50 degrees. What would angle C be? 130 degrees. So if angle C is 130 degrees, because these will be the same measure, because angle C can't be different, it is what it is, what would angle B be? 50 degrees. What can you conclude about angle A and angle B? They're congruent. So your conclusion is that angle A is congruent to angle B. This is missed all the time on a test. All the time. So when you see something like this, put some numbers to the angles, and then when you look at the numbers, it'll be obvious to you. When you look at it without the numbers, it's not quite as obvious. Can I erase that? All right, we're going to see the same thing, but with complementary. And again, this also most likely could be on your test next week. Angles complementary to the same angle or two congruent angles are congruent. And I'm going to give you a slightly different example with this one that will relate to the or congruent angles part. And again, this would be the shorthand notation that you can use in your proof. Instead of having to write all of that out, you can write it in shorthand. So if I were you, I would star those two, because again, it's one of the highly missed questions on your test because you're not studying, so you need to actually study. Alright, so here's an example I might give you. So here would be statement 1. Angle A is complementary to angle C. Angle B is complementary to angle D. Statement 2 would be angle C is congruent to angle D. What is your conclusion? Well, let's put some numbers out there. What do you want A to be? 60. So if A is 60 degrees, what would C be? They're complementary, what would it be? 30. If C and D are congruent, what does D have to be? 30 degrees also, right? Because of this, I have to make D 30 degrees because they're equal. So what's B? 60 degrees. So what's your conclusion? Angle A is congruent to angle B. And that's all it's saying. If angles are complementary to the same angle or congruent angle, so I've got angles complementary to congruent angles. The conclusion is that those angles are also congruent. All right. Little bitty theorems. Stuff you should already know. This is kind of a no-duh theorem. Theorem 2.6, all right angles are congruent, because what's the measure of a right angle? 90 degrees, so that makes sense, right? But the reason why we have a formal proof or a formal theorem behind this is because we're using this in our proofs. And you can't use a statement of fact in a proof if there's nothing official behind it. For instance, you would not be allowed to say that I had blonde hair if you didn't officially prove somewhere along the line that I was born with blonde hair. Looking at me and you're like, yeah, of course you have blonde hair. Perhaps I dyed it. Maybe I was a redhead. All right, this one. We should already know this one. Vertical angles are congruent. But now all of these are things you're using on the reason side of your proof. So if you're given a picture in your proof and two of the angles are vertical, you can immediately make a conclusion that those angles are congruent, and your reason would be vertical angles are congruent. Just by looking at that picture. And then the last one here. Perpendicular lines intersect to form four right angles. Theorem 2.8 goes with Theorem 2.6. If I have a picture of perpendicular lines, my conclusion is going to be that they form four right angles. Then my conclusion from there would be that all right angles are congruent. So I can string those together. So you remember the book, If You Give a Mouse a Cookie? Then he wants a glass of milk. If you give him a glass of milk, then he has a milk mustache. This is where all these things start following one right after the other. And then we have one problem to do. Can I take that away? All right, so here we go. Your one and only example. You can call example 1 if you like, but it is the only one. If angle A and angle C are vertical angles, and the measure of angle A is equal to 3x minus 2, and the measure of angle C is equal to 2x plus 4, find the measure of angle A and the measure of angle C. So we're going to practice that 4-step plan again. You only have to do the 4-step plan if your problem is written in word problem format. If it's not, then you don't have to, but we're practicing it so that anytime this occurs, you'll be in the habit of showing your work properly. So there's no picture. You should draw a picture. How are vertical angles formed? What intersects? What kind of things?
There are 2 angles.
But what makes up those angles? What kind of things? What things? Lines. So we have 2 lines that must intersect, and so Seth is right, it looks like an X, to form 4 angles. We've got 2 sets of vertical angles. 2 are obtuse and 2 are acute. I don't really know whether my angles are obtuse or acute. It doesn't really matter for our purposes here. Let's say that I put A and C here. I could be incorrect in putting them in the acute spot, but it really doesn't matter if they turn out obtuse. I'll still understand what's going on. So then I also need to put in my let statement here, what does angle A equal? We were told that it was equal to 3x minus 2, and then angle C is 2x plus 4. Over here you should be setting up your equation to solve. What is the relationship between these two angles? They're congruent, right? Vertical angles are congruent. So that should be telling you right there, the fact that they're congruent, that you are setting them equal to each other because you're trying to figure out what's your equation to solve. So you ought to be able to solve that algebraically. So go ahead and solve it algebraically and answer your question. So solve straight down here. This is where all your algebra goes, bless you. When you solve for x, does that answer the question? No. So make sure that you answer the question. When you get the answer, share it with those around you. Share. That means you have to talk. What'd y'all get? All right, so how are you going to answer the question here? This should be a complete sentence right there. How are you going to answer that? Therefore, what's the question asking? Yeah, so therefore, the measures of angle A and angle C, I should have said are 16 degrees.